This is an introduction to Ovalview. We'll cover what Ovalview is, how it can help you, and we'll throw in a little bit of how we got here kind of history. The goal of Ovalview is to simplify the management of a feature for the engineering team. Ovalview helps the engineering team by reducing the cognitive load required when managing the number of tasks involved in large projects. Rather than having to deal with potentially pages of tasks, such as demonstrated here, the team are now presented with a visual representation as demonstrated here. This provides context for each of the tasks and the relationship between those tasks, and immediately you understand where they all fit into the project. So let's dive into how we get here. So this is Ovalview. We'll quickly sign up. Sign in already. And we will create a new page. We will assume that the work has been done on the use stories and the acceptance criteria required, and there will have been an iterative process helping flesh out the high-level design. And it's the high-level design that we need to take to use for the tasking. So very briefly, we have a high-level design that's been produced, and this is what we will use for identifying the tasking. The reason we're working this way around is in the past, we've worked with lots of stories, use cases, acceptance criteria, and the traditional step is to then breaking out into the tasks. And often we find that there are gaps appear in the tasks when completed, and these only become visible at the end of the story. So the trouble with the long list of tasks, and I know that tools like Jira have facilities to help manage these, such as prioritizing and block this task blocks this. But this becomes very complicated to manage in your head. It feels like you're trying to manage a Gantt chart, but without the visual aid. We also found that when we had identified gaps at the end of towards the end of a feature, that we would refer back to the design to identify what those gaps were and how we should address these. So cutting out the middleman, which is the creating the task, having the error, and then referring back to the diagram, we're starting from the diagram to identify the work that needs carrying out. We do this simply by annotating the design and working from the design. As an example, the quote service receives a request from the broker app. There is an endpoint that needs to be defined here. A request will be accompanied by a response, so let's now define that response. So we'll build a canned quote response there, and we have a consumer for this. So we could, the actual minimum is that we could just test this via the command line using curl, but we've got a broker app here. We know there's a UI team involved, so we will add that. Display quote, and obviously this broker app will need to make a call to get quote. Get quote. We can add further details here, so these will no doubt be called out in the ASCs, but if we just add a note, for example, header includes customer ID. I'll add a couple more tasks to this diagram to give a flavour of what a more filled out solution will look like. In this instance, we're using a mock to potentially save the client money when making calls to the FX provider. We'll assume we require a standalone skeleton service for this. We'll assume we can spell service. And we will provide canned response. Great. And we'll add a note that this canned response is limited to a subset of currencies. So we have a very basic outline here of what we're going to achieve. Again, with the initial goal is to demonstrate to the stakeholders that we want to show progress. So immediately we assign a user to this one. We've imaginatively called the first user 1, and mark this task as in progress. So the tasks that are color coded: red is to be done, amber is in progress, green is completed. So we'll also assume that the canned response has also been picked up by user 1. That is also in progress. The UI in a separate app, the broker app, we can see from the diagram that this can be developed in parallel. So we'll assign that to user 2, also lacking imagination, and mark this task as in progress. So looking at this, we can now see that user 1, user 2 need to communicate. They can see the state of the feature, what work is in progress. This works really well if you use this for a stand-up scenario. So rather than everyone standing and doing the job justification routine that you see in too many companies, you bring up the diagram. We're working on this feature. Where are we? User 1, user 2 can give updates. We can see if there's another user available, another engineer available. Then they can pick up some of the tasks that are not currently inactive. So what we can do now is that we can enable Jira for this integration. And if we enable Jira, we saw that it created a link to a ticket, and it's just created a skeleton ticket for this. If we now go back and synchronize with Jira, now what has happened? So we can see that the quote service task by user 1 also has a task ID. So if we jump back to the story and refresh, we can see that all those tasks have now been created in Jira. As discussed before, one of the problems that we had with just using the Jira approach and just creating tasks for stories is that you lose the context. And already we've only 6 stories in here. It's difficult to place exactly what is going on. You need to have that mental model in your head. It's much easier if you can then just refer to the page and you can see which tasks relate to each other. So not only helpful for the engineers actually doing the development, they get the context of the tickets, they get to understand which tickets relate to each other and opportunities for parallelism. There is also a great benefit here to the Scrum Masters, the project managers. By quickly looking at this, we can see that this feature is in progress, and we can see how much work has been completed. If we mark this as done, we might assume the end bit has been done and the call has been made. So from a product point of view, we can now see exactly what needs to be done to deliver the minimum. This should be fleshed out at the stand-ups, or the engineering team themselves will jump to these conclusions. From this, it's very obvious that display quote needs to be picked up. So we assign that to user 2, that's in progress, and we can now see that we're very close to having the delivery of the minimum. So in a nutshell, we provided a visual reference to the feature that is working on and avoided the long list of tasks that often lack context and lack the glue between them. Whereas when using the diagram, you can see which tasks need to be picked up and you can allocate them on there. Having identified all the tasks required, you can see that there are no gaps, and you can then start to allocate these and work out what is the minimum path. Obviously in this example, we've just gone for the minimum path. It gives you the visual feedback, so you can immediately see how much work is being done, and you know which task needs to be picked up next. You've avoided going through the prioritization exercise that is required in when using Jira and just lists of tasks. you can see here what is actually required. Of the organisations where we've demonstrated this technique, they all still use it, which is a fantastic testament. So this isn't an idea that's just been thrown out there and hoping it gets adoption. This has been built from the coalface. This has been designed to address problems that real engineers have had. If you want to give this a try, it's overview.io. You can run it just as a single member of the team signing up, or you can have all your engineers sign up and create an organisation. We'd love to hear your feedback and how you get on. Thank you very much.